We're going to solve this using the quadratic formula because that's what they tell us to. We want to make sure, we notice it's a k squared. So if it has a squared term, we move everything to one side, put it in the standard form. And it is in that form. We have 2k squared plus 8 plus k minus 8. So it's in that form. Then we want to identify the a, b, and c. Remember, this is the a, so that's 2. The b coefficient is understood to be a 1, so that's a positive 1. And the c is the constant term, that's negative 8. So that's what we're going to plug into this formula over here. So I have x equals negative b. Now negative is part of the formula, and then whatever b is, that's 1. So if b had been a negative 1, then we'd have negative times negative 1, so we'd have a positive 1. So be careful about that. Plus or minus, then b squared, which is our 1 squared, minus 4 times our a, which is 2, times our c, which is negative 8. Be careful with the signs. And all of that is over 2 times a, and a is our 2. So let's simplify. We have negative 1 plus or minus the square root of 1 times 1 is 1. Negative 4 times 2 is negative 8, and negative 8 times negative 8 is positive 64. And then in the denominator, 2 times 2 is 4. So that is 1 plus or minus the square root. 64 plus 1 is 65, divided by 4. So now the square root of 65 breaks down to 5 times 13. And 5 and 13 are both prime. 5 times 13 multiplies to 65. So there's not a perfect square in there, so we cannot break it down. So when we write our answer, we could write this as an answer, or what they're going to have is they're going to take it and write it twice. They're going to write 1 plus, oh, notice my mistake. I didn't carry the negative 1 over. Make sure you carry that negative 1 over. Okay, so negative 1 plus the square root of 65 divided by 4, comma, negative 1 minus the square root of 65 over 4. The only difference is you're separating out this plus and minus right here so that you write it twice. This is what the book will have. Not the book, the software.